Hola, hola, welcome back. This one is in continuation to the previous video, which was also composition of trig functions. I'll write it here. Composition with trig functions. But in the previous video, watch the previous one. Basically, I'm trying to say is watch the previous one before you watch this one. Because in the other one, we had examples like where we had the same trig function composed. So if I have sine, I had sine inverse of an x value, which equals x. If there was cosine and then we were composing it with cosine inverse, so inverse of itself, and the answer was only x, and then where we had restrictions with x values. So this one is in continuation. What happens when we are composing unlike trig functions? Here's an example, jumping straight to examples. Let's say I have sine function composed with tangent inverse of half, and then I need to find the answer to that. This is the one where one is sine and one is tangent inverse, so obviously I can't cancel them out. I can't really cancel them out because they're not inverses of each other. When that happens, we kind of go back to the idea that because I have composition functions, I'll have to look at the inside one first. That's the one I need to figure out first. So this one's basically asking me that tangent of a certain angle theta, the value is half. The inside part is an inverse function. So the way you want to read it, again, I'm repeating myself here, you want to read it as the orange part is basically asking you tangent of what angle is half. Okay. Now tangent half value is, again, check the chart first, but if you look at all the green values here, tangent is not half on the chart. So what I'm trying to say is it's not on the chart. Well, then that creates two problems. What do? It's not on the chart and I can't cancel them. So we start doing something like this. First of all, you look at what's on the inside and you say to yourself, hey, this is a tangent inverse one. I should be restricted to quadrant 1 and 4 only. The values or the answers should be restricted to quadrant 1 and 4. So I am restricting myself to quadrant 1 and 4 only, and if you notice, I'm not even drawing the other two quadrants. Then between the two, we think again. We say to ourselves that the tangent value here is positive. The answer, whatever that angle is, the answer to that is positive. And what I want to tell you is that tangent value is positive in the first quadrant. In this fourth quadrant, tangent is negative. In fact, for that matter, all values, all 6 trig functions are positive in the first quadrant. Tangent is also positive in the first quadrant. Tangent is positive in the third quadrant as well. And then tangent is negative in these two quadrants, second and fourth. So that actually helps us narrow it down to just first quadrant. It's like this has to be in the first quadrant. So bottom line, I am only going to focus on first quadrant. Now we are getting to the point where we're saying whatever that angle is, it's in the first quadrant. I don't know the angle, but I do know it's in the first quadrant, and the tangent value of that angle is half. So I'm going to go ahead and construct that angle starting at the origin. I'm going to construct that angle, call that theta, and complete the triangle from there. Make a right triangle from here. Now I'm going to go ahead and focus on the SOHCAHTOA part. Let me write it here. The SOHCAHTOA, just a quick reminder. SOHCAHTOA is an abbreviation. To get sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And this is the tangent one. Tangent is opposite over adjacent, which tells me this must be the opposite, and this must be the adjacent side. Let's quickly highlight our opposite and adjacent. This one's clearly the hypotenuse. This is opposite, and this is adjacent. So opposite has to be 1. Adjacent needs to be 2 here, and the one unknown is the hypotenuse. But if that makes sense, we have completed or figured out 2 sides of the triangle. We still don't know the angle, but we have figured out 2 sides of the triangle. Can I find the third side? Yeah, very simple. It's a right triangle. It better follow Pythagorean theorem. 1 squared plus 2 squared must equal c squared. 1 squared is not 2, equals c squared. 5 equals c squared. And what does c equal? Square root both sides, square root of 5. Am I going to pick up my calculator and find the decimal value of that? Nope. It's going to be an unending decimal, and that's not going to be an exact value. So I found it. The value of, or the length of this hypotenuse is square root of 5. Now that I know all sides of the triangle, I know adjacent, I know opposite, and I know hypotenuse. Now look outside. What do I need to find? Ultimately, what do I need to evaluate? I need to evaluate the sine value at that angle. I need to evaluate sine value at that angle. Sine of whatever this angle is on the inside. Sine is opposite over hypotenuse. So the overall answer here should be opposite, which is 1, over hypotenuse, which is root 5. I really want to say that is the answer, 1 over root 5, but then you all know that's not an acceptable answer just because we have a radical in the denominator. So let's quickly rationalize it. Numerator is root 5, denominator is 5. So sine of tangent inverse of half is root 5 over 5. Yes, it's a little bit of work when they are different inverses, and we can't cancel them. Yeah, we got to take another route here, and that's the route we must take. I shall show you more examples, of course. Cosine, sine inverse, negative 1/3. Ta-da. Clearly, I can't cancel them. Okay, can't cancel them. I need to start from what's on the inside. Composition function rule, start from the inside. So I'm like, this is an inverse question that's asking me for an angle where sine value is negative 1/3. Sine value is negative 1/3. Sine is restricted in quadrant 1 and 4, right? But in quadrant 1, all values are positive, and I'm looking for negative 1/3. So this must be in quadrant 4, guys. It must be in quadrant 4. No other choice. I shall only focus on quadrant 4, which is this big one. And over there, I'm going to draw that angle, call it theta. Again, I don't know the value of theta. And it went this way. I'm going negative. I don't know the value of theta. But I do know it's in the fourth quadrant because the sine value there is negative. And let me complete the triangle. Let me identify in my mind that, wait a second, this is the hypotenuse, this is the opposite, and this is adjacent. Okay? Now sine is opposite over hypotenuse. So this must be the opposite, and this must be a hypotenuse. Let's label it opposite negative 1, hypotenuse 3. Right? And you see how clearly negative 1 actually makes sense? Because we're in the fourth quadrant and we're going down. We're below x-axis. And then y value should be negative. But anyway, now can I find adjacent? Yay, we should be able to find it. A, negative 1 squared. B is unknown. Actually, I must call it the other way around because adjacent is unknown. So let's pretend this is the A part, adjacent. We don't know adjacent. So A squared plus B negative 1 squared. C3. What's negative 1 squared? It's positive 1. 9, subtract 1 from both sides, square root both sides, root 8. This is root 8. And now that I know all three triangles, look on the outside. They want me to find the cosine value at that angle. Cosine is adjacent over hypotenuse, which is 3. And that should be the answer. Except I'm going to tell you one more thing. This is not simplified all the way. The reason being, square root of 8 can be written as the product of square root of 2 and square root of 4. Right? Y'all have to agree, right? 8 is basically 4 times 2. And then this here, square root of 4, we would never write square root of 4 as square root of 4. We would rather change it to 2. So let's erase that. A better way to write that is 2. And this is simplified form of writing root 8 over 3. And we shall have completed that question. Fun? Having fun? I have one more to show you, just for practice. Tangent, cosine, negativo, and then negativo 1/3. And I have to find the answer to that. And clearly I can't cancel tangent and cosine inverse. So we shall begin with what's on the inside. And I am now thinking to myself, this is a cosine inverse question. Cosine is restricted to 1 or 2. So we are either in this or this quadrant. But then cosine value is negative. Where is cosine negative? Well, in the first quadrant, everything is positive, so can't be first quadrant. This is in the second quadrant. Whatever this angle is, it's in the second quadrant. And this one, the big one, this is the second quadrant, so I made it bigger and clearer. Now that I know it's in the second quadrant, I shall draw an angle. Call it theta, connected to x-axis. Make it a right triangle. And I go back to my cosine. Wait a second. Cosine is adjacent over hypotenuse, so I know some stuff here. This is adjacent, this is hypotenuse, and this is opposite. Adjacent is -1. Let me change the color. Let's use green. -1. Okay. Hypotenuse is 3, and this is what we don't know. Right? Let's call it B. B is what we don't know. Okay, we can do that. We are pretty smart people, aren't we? A squared plus B squared equals C squared. -1 squared plus, this turns out to be the same as the previous one. Funny. B is unknown. C is 3. 1 plus B squared equals 9. Subtract 1. Square root of 8. Okay, found it. Square root of 8. So this side is square root of 8. Now look on the outside. I have all 3 sides of the triangle, and I need to find the tangent value there. Tangent value there is opposite, which is √8, over adjacent, which is -1. Interesting. I really don't have to write -1 at the bottom. I can just call this -√8, right? So that's the answer, but I was like, wait a second, √8 is not simplified all the way. √8 can be written as √4 times √2, and then √4 is never left like that. We shall use 2 for it. So -2 √2 is the simplified form to accept that answer. So these are 3 examples of when we have 2 different ones. Actually, I saw one Math Excel one, sorry, added it. I just realized it was a Math Excel question. √2 over 2. And the reason I'm showing you this is because it's easier. Again, obviously you can't cancel them. You have to look at the inside part, but always look at the chart first. If you find this on the chart, then make your life easier. So let's go find, do we see sine value √2 over 2 there and get the corresponding angle from there? Because this is asking me what is the angle when sine is √2 over 2. Sine value √2 over 2. And I'm not even going to look onto this side. Right? I'm not going to look at anything from here because this is a sine question. √2 over 2. I found it. Right? So what's the angle? Pi over 4. Didn't have to construct that triangle. It's pi over 4 when sine value is √2 over 2. Okay. So I found that angle actually. So the theta is pi over 4. So the inside part is pi over 4. Now look at outside. So it's cosine of pi over 4. Yeah, at that same value I have to find, at that same location I have to find the cosine value, pi over 4. Cosine value there is 2 over 2. The answer is √2 over 2. No need to simplify or anything. So although this is the exact same type of question that I was doing previously, but because the value was existent on the chart itself, it made my life much more easier. Okay. All right, that's it for this. I shall see you soon in class. Have a good one. Bye.